Hi! Today we're going to learn about the washer method in calculus. Let's say we have to compute the volume of f of x is equal to x plus 2 revolved around the x-axis from x equals 5 to x is equal to 11. So let's first draw out what we're looking at. So let's first make the axis. So because we know that revolving it around the x-axis will make it a solid, then let's do this, and the solids are 3D, then let's do this with x, y, and z. So we have the x-axis, which is just going to be diagonal. Then we have the y-axis, which is still perpendicular to the x-axis. So x, y, and then the z-axis, which is just a straight line down. Hopefully that's what it looks like. The z-axis. So here we have x, y, and z. Now we know that if we have x plus 2, then that's like a linear line from, let's say, here, and it just increases like this, let's say. So let's say that's what the line looks like. So if we revolve this around the x-axis, then we'll get sort of like a figure like this. And this is shaded in. So now we know that we have to do this from the point x equals 5 to x equals 11. So let's draw this from that point, from one point to another. So we know that this drawing will look somewhat like this, where it's like a cone that has been sliced off at two ends, or sliced off at that one end there. So this is at where x equals 5, this is at x equals 11. So I hope this looks more realistic, and we can see that because we know that this line here is revolved around the x-axis. And we know that this isn't going to both meet at a point because x equals 5 is not 0, so when you plug it into here you get 7, and so that means that it won't reach the same destination point of 0 because when we revolve we will get the points 0, 7, 7, 0, so we will get the points 0 and 7. Then when we revolve it clockwise, we would get to the point 7, 0, then something like this, negative 7, 0, and like 0, negative 7, or something like this. But we know that it won't meet up at a common point, we'll just have a circle at the end. But that's besides the matter right now. So today we're going to learn about how to compute the volume of the solid here. So we're going to use this one formula called the washer method. So the washer method says that if you have a solid, or if you have a line, or anything, a curve, that you want to rotate around the x-axis, and it has to be the x-axis, to create a solid, then the volume of that solid will be, pi times the integral from a to b of that function squared. So this is the formula for the washer method. So let's apply that to our problem here. And also, if you're not revolving it around the x-axis and you're doing something different, you do not need to include the pi, and you need to change up whatever's in the integral a little bit, but there's still going to be an integral and an integrand. So here we can see that we have to revolve this line around the x-axis. So we can just use the washer method. So the volume would be equal to pi times, now we know this integral is going to go from 5 to 11, times f of x, which is x plus 2 squared. X plus 2 squared. This gives us the volume is equal to pi times the integral from 5 to 11 of x squared plus 4x plus 4, which would be equal to pi times the integral of x squared plus 4x plus 4, as we know, would have to be equal to x cubed over 3 plus 2x squared plus 4x from 5 to 11. So we get this thing here. So now we have to plug in 5 and 11, and we get this would be equal to pi times, now if we plug in 11, we get 11 cubed over 3 plus 2 times 11 squared, 2 times 11 squared plus 44. So let's move this over a little bit so we can see it. So, and take a moment to look at this because I'm going to erase it soon. As in right now. So this would be equal to pi times, in parentheses, 11 cubed over 3. 11 cubed over 3 plus 2 times 11 squared, which would be plus 2 times 121 plus 4 times 11, which is plus 44. Now we have to subtract this value that we got. Now we have to subtract whatever we get when we plug in 5. So we get 5 cubed, which is 125 over 3, plus 50, plus 20. So we have to subtract this from this value up here. So we get, this would be equal to pi times 11 cubed over 3 plus 242 plus 44 minus 125 over 3. So now that we have minus 100, and let's rewrite this with more space between them. So we get 11 cubed over 3 plus 242 plus 242 plus 44. Now let's combine like terms, even though they're all constants. Let's sort of combine them by the denominator and what place they are in. So we have 11 cubed minus over 3 minus 125 over 3. 125 over 3 can be simplified down to, or it cannot be simplified down, so we're just left with 125 over 3. So we can combine these two to get minus 125. So we get 11 cubed minus 125 all over 3 plus 242 plus 44, which combines to be equal to 286. 286. Likewise, 50 and 20 combine to be equal to 70. So we can subtract 70. So this combines to be equal to 70. So we can subtract 70 from 286 to get 216. So we are left with pi times 11 cubed minus 125 over 3 plus 216. So let's rewrite this as our final answer. So we get pi is equal to 11 cubed minus 125 over 3 plus 216. Today we learned about the washer method in calculus. Thank you for watching this video. And also, this would have to be units cubed. Once again, today we learned about the washer method in calculus. Thank you for watching this video.